In this video, we're going to go over how to reflect a geometric shape, which could apply to a point, a line, or a polygon like this one, over a line of symmetry, so reflection. So the directions here say we're going to do a reflection over the line x equals -1. So first step is to draw that reflection line. X equals a number is a vertical line. If it was y equals -1, it would be a horizontal line, but it says x equals -1, so we're going to draw in that vertical line. So this is the line of symmetry, or the line of reflection. I suggest when you do this on paper, you do it dashed. Let's see if I can accomplish that. Oh, look at that. So let's make it dashed, because it's not really there, it's just there to guide us. So there's my line of symmetry, or my reflection line. So there's no point mapping rule for a line like this, just for the x-axis, y-axis, y equals x and y equals -x. So this you really just have to do visually, unless you consider this like a different y-axis and point F here as the new origin. That's possible. But it's just very simple to do visually, because if you notice point A, it's 2 units to the left of the line of reflection. So it's going to be 2 units to the right. Same thing with B, it's going to be right here. And you could almost visualize where everything's going to be. Like D is to the left to A, so D prime would be here. We'll just call it I. C would be here. And then we can connect all those points and get our image from the pre-image. And that's a reflection over that line. And you could see that if I folded these two shapes together, where the folding line was line EF, they would fold completely on top of each other. So now let's try a reflection over a different line. So let's change the directions, to be a reflection over y equals x. Y equals x has a slope of 1 and a y-intercept of 0. So I can create the line just by the fact that it'll go through 0, 0, and 1, 1. And now I need to reflect all my points over this line. Now, what's going to happen is that this is a little harder to do. Like, there is a point mapping for this that every xy will map to. So xy will map to yx. If it was y equals -x as the reflection line, it would go to -y -x, and that's just kind of something you can kind of memorize or see visually. But I don't really want to do that. So let's see, if I construct a perpendicular line, where's construct? Here it is. So let me construct a perpendicular line from this line going through this point. So B and D, when I reflect it over, will be on the other side of the reflection line on this line, because this line is perpendicular. So that's kind of hard to visualize. So what I actually do is I see how I can travel from B to the line of reflection. So for B, I can go to the right 3 and down 2. And what I'm going to do is instead go to the right 2 and down 3. And that's where B prime is going to be. So you can actually kind of visualize it as making like little symmetrical shapes, kind of like an M here. This is how I journey from B to B prime. It's kind of, I think, okay, right 3 down 2 to a point on the line. So I'm going to go switch it and go right 2 down 3. And you can kind of see how that's reflected over that line. Oh, I don't want that to go away. Come back. Whoop, don't want that as well. Okay, so I'm just going to erase all that, because it's kind of, you think about it and then you are done with it. So now D, I can see, will be 2 squares that way. Now A, I go right 3 down 4. So I'm going to go right 3 or 4 down 3. So it's going to be here. Right, to make an M that's the same. So if it's 3 and 4, I'm going to go 4 and 3. So there's A prime, and I just need C. So C, to get to the origin, I go right 6, down 3. So I'm going to go right 3, down 6. And let's look at that shape when I connect the points. What's nice about this is you can always check your work with the symmetry. You can check your work with the point mappings, which is nice. And if I tilt my head, obviously you can't see me, but I'm tilting my head so that it's looking at it, and I can see everything's reflected, everything's equal distance to the line of symmetry as their point mapping. So I'm going to hide this line, not show object, and then we can see that this is the reflection over that line. Now let me double check with my point mapping. So what should have happened is every point should have just switched. So if this was -3, 4, I should have 4, -3. Good. D is -5, 4. I should have 4, -5. Okay, everything checks out. So you can kind of visualize your journey to a point on the line and then do the opposite, right? If I went 3, 2, I'm going to go 2, 3, kind of in that same direction. So that's reflections. Dun, 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 dun.